So we have two balls, A and B, moving with velocity 25 centimeter per second and 15 centimeter per second. So I change the velocity to meter per second. So it will be 0.25 meter per second and 0.15 meter per second. It's moving in opposite directions on the table. So the ball collide with each other and bounce off. The mass of ball A is 20 grams. So 20 grams is 0.02 kg and ball B is 25 grams. So the mass in kg will be 0.025 kg. So we need to calculate the final velocity of ball B and its directions. If the final velocity for ball A after collisions is 10 centimeter per second, change it to meter per second, it will be 0.1 meter per second. So if after collisions ball A move off at 0.1 meter per second at an angle 35 degree in these directions, so we need to calculate what is the final velocity of ball B and in which directions. So again, this is a 2D collision. So first step, we need to break the velocity into X and Y components. So before collisions, we only have the motion along the X directions, whereby the initial velocity for ball A along the X directions will be 0.25 meter per second. For ball B along the X directions, it will be 0.15 meter per second. But because the directions is leftward, so I should put a negative sign for the initial velocity for ball B. Then after collisions, the final velocity of ball A, I can break it down into two components. So I'm going to have the final velocity ball A after collisions, VAX, which is pointing leftwards, so it will be negative 0.1. I'm going to have cos because this component X is attached to the angle, so cos 35. Then I'm going to have a vertical Y component for VA. So we have VAY is 0.1 sine 35. So this component is positive because the direction is upwards. And the final velocity of ball B after collision also can be break down into component X and also component Y. So we are going to determine the X component and Y component of final velocity ball B in order to calculate the magnitude of VB. So after we break down all the velocity into X and Y component, then now I can write the conservations of momentum for X and Y separately. So we do it for the X direction or the X component first. So the total momentum X component before collisions must equal to the total momentum X component after collisions. So before collisions, we have ball A moving rightward at 0.25 meter per second along the X axis. So 0.02 multiplied 0.25. Plus we have ball B moving leftwards with a velocity of 0.15 meter per second. So we have the mass 0.025 for ball B and the X component for the ball B before collision should be negative 0.15. Okay. Then after collisions, we have ball A moving leftwards with a velocity negative 0.1 cos 35. Plus with ball B is moving with a velocity VBX. So we can determine the X component for the final velocity ball B VBX. It will be around 0.116 meter per second. Okay. Then I do it for component Y. So for component Y, again we have total momentum component Y before collisions. must equal to total momentum component y after collisions. So before collision, both ball is only move along the x direction, so there will be no component for y, so the total momentum along the y component before collisions is 0. After collisions, the ball A is moving upward with a velocity 0.1 sine 35 degree, and the ball B also have a velocity along the y-axis. So we have 0.02 for ball A. The final velocity for ball A after collisions, component Y is 0.1 sine 35 plus V, ball B 0.025 VBY. So I do the calculation, I'll get the VBY will be negative 0.046 meter per second. So the negative sign in the answer will telling us that along the y directions, the ball B is moving downwards. Okay. So after we get the component x and component y for final velocity ball B, then we can calculate VB using the theorem Pythagoras. So VB will be VBx squared plus VBy squared, square root. So along the x component, the final velocity for ball B is 0.116 squared. Along the y direction is negative 0.046 squared. So I'll get the velocity for ball B after collisions is 0.125 meter per second. How about the direction of the ball B after collisions? So the direction of ball B after collision I can determine using shift tangent VBY over VBX. So I'm going to have shift tangent negative 0.046 over 0.116. So I'll get the angle will be negative 21.6 degree. So refer to the component. So our component y for the final velocity ball B is negative. The component x is positive. So this angle will be below positive x. We have determined the velocity of ball B after collisions is 0.125 meter per second, and then at the direction 21.6 degree below positive x.